Hello, my name is Bill Hunt. I'm the CTO of Dynamic, and today I'm going to walk you through our FogMan product, which is a centralized management platform for managing fog lamp edge devices. So this is the architecture that we're going to walk through in this demo. We have 2 fans on the left and 3 pumps on the right, and then various fog lamps that are monitoring them. In the demo, the fans and pumps are simulated, but the fog lamps and Pi servers and FogMan are all real. So on the left we have fan 1, and fog lamp 11 is measuring speed and vibration from it, and similarly for fog 12. And then fog 21 is measuring leakage, temperature, and vibration data from pump 1, and then similarly for fog 22 and fog 23. And then we also have 2 fog lamps that have been brought up but are not part of FogMan. So they're running outside of FogMan. And then we'll have 2 pumps that we'd like to be associated with those fog lamps. So in this demo, I'm going to walk through how you can monitor the existing infrastructure, and then also how you can introduce these new fog lamps and how you can connect them, in this case, from the pumps to the fog lamps to the Pi. All right, so this is FogMan, and FogMan breaks the world into 3 sections. So there are the fog lamps, of course. That's the devices that actually are managed by FogMan, and we've got some detail about them. I'll go into that in a little more detail. And then on the south side of those fog lamps, we have machines that are being monitored by them, and we have sensors that are connected to each of those machines. And so in this case, we have fans and pumps, but we could have other kinds of machines or other kinds of monitored situations as well. And in this case, you can see that the 2 fans are monitored by these 2 fog lamps, and the 3 pumps are monitored by these fog lamps. And then we have 2 new pumps that I've introduced, but they are not connected to anything. And then on the north side of the fog lamps, we have external systems. In this case, we have a Pi server, but you could be sending data, say, via Kafka or to GCP North or another destination. And so here we can see the Pi server is connected to all 5 of the fog lamps. All right, so going back to the fog lamp page, we can see that each of the fog lamps has a green dot next to it, and that indicates that it's healthy. So FogMan is continually monitoring each of the fog lamps and making sure that they're healthy. And if you hover over the green dot, you can actually see some more detail of what's going on inside those fog lamps. So in the case of fog 23, we can see it has 3 south services for each of the 3 sensors, and they're all doing as would be expected. So these devices are all healthy. And then we can also see the ingress, this column. We can see the data that's flowing into each of the fog lamps, and the egress, we can see all the data that's flowing out of those columns. And this page updates every 20 seconds, so periodically you'll see these numbers change. Then we also have columns for the connections for each of the fog lamps. So in the case of fog 11, we can see that it's monitoring, it has connections to speed and vibration for fan 1. Similarly for fog 12, and for fog 21, we can see that it's got connections to pump 1 for leakage, temperature, and vibration, and similarly for fog lamps 22 and 23. And then for each of the north interfaces, we can see, first of all, I should mention that these icons exist that indicate that a connection exists at all, and then hovering gives you details of them. So in this case, we can see that each of them are connected to that central Pi server. And as I say, in the machines, you can see which machine is connected to which fog lamp. In the external systems, you can see which external system is connected to which fog lamp. So if we walk into the history page, FogMan has a robust versioning system. And in this case, this shows you the history of what I've done so far. So in version 1.0, what I did is I added the fog lamps. And then in version 1.10, I added the fans and the pumps. In version 1.2.0, I connected those fans and those pumps to the fog lamps, so I was collecting data from them. And then in version 1.3.0, I set up a Pi server and I connected it to the fog lamps. Now you can do all this stuff at once and roll it out at one time, but there's a value in being able to stage it and do things one step at a time. That way you can always back out of something if you'd like, or you can go see how the world existed in a previous state. And if I want to see more detail about each of those, I can click over here. So in 120, this is the stage where I connected the fans and the pumps to the fog lamps. I can click that. And I can see here are all the things that I did in that phase. So for example, I collected from fan 1, I collected the vibration data and sent it to fog 11, and similarly for other changes. And we could walk through all the other versions and see similar changes. We can also see at the top that this says live, version 130, so that's the version that's actually out in the world. That's what's deployed on the real fog lamps. So you can also go and see how the world existed on these other screens at previous versions, which is very useful for debugging or planning. So for example, if I click on this 120, and remember this is the version before I set up the Pi server and connected the fog lamps to it, I can go and see how the world looked on these screens. But first, we notice that at the top, we get a warning that you're looking at version 120, and this is a historic version for reference and can't be modified, and this is not what's currently deployed. So that way you know this isn't what's actually out there and you don't get confused. So if we go back to the fog lamps page, we can see that now everything's the same except there are no north connections. And we can see in the machines page, of course, stays the same. And in the external systems, there is no Pi server and there are no connections to it. So this is valuable to walk back to previous versions and see how things looked. So now, as I say, I've actually set up 2 fog lamps and they are now running, but they're not known by FogMan. So we'll introduce them into FogMan. So what I'll do is I'll create a new version. I'll call this version 1.4.0. And I'll say add fog lamps, and we'll collect pump data and send it to Pi. Now, the version can be based on any previous version. So the default is to just use the live one so that you're constantly moving it forward in time, and each of those versions is linear. But it doesn't have to be that way. You can define hierarchical versions. So we could base this on a previous version, and we could actually have multiple working versions in process so that you can be staging one kind of thing and staging another kind of thing and working with them in parallel. But in this case, we'll just make the last version, or we'll base this on the live version of 130. So I'll create that version. And now I'll walk back to the fog lamps, and I could manually add a fog lamp at this point. And I could go in and I could type its name and address and various ports and so forth. But FogMan and FogLamp have a auto discovery feature. So we can just click this discover button, and now FogMan will search for any new fog lamps that have appeared. And if I refresh, I can actually see we've got fog 24 and fog 25. Now you notice they don't have green. In a second, they'll turn green, and they just did. And that's because as they're being brought into the domain of FogMan, as they come up, they get monitored. So now they're being monitored, and you can see fog 24 it has only the storage in the core inside it, as opposed to say fog 23, where you can see components running that are monitoring leakage temperature and vibration. So as you'd expect, there's no ingress for these two systems. There's no egress. There are no north connections. There are no south connections. And bear in mind, this is only what we're seeing here is only what lives in FogMan. We're not going to change. We haven't changed anything in the real world yet. So what we'll do now is, if we go to the machine section, and pump 4, we'll set it up to be monitored by FogLamp 24. So we see we have pump 24. We'll add a connection. Let's say we'll pull leakage data from that. So we'll say pump. We could name this anything. Pump 4 leakage, and the fog lamp will send it to fog 24. And then we have a series of properties which are specific to this type of connection, this type of sensor. And these properties can be quite simple. There could be no properties, or they could be quite complex. If you had, for example, some robotic arm with hundreds of various data points or various configuration points, then you could have quite a complex property set here. In this case, there's really just one property, which is the asset name. And we could enter in here a name, we could call it leakage, for example. FogMan has a series of variables that you can use that allow you to scale your deployments. It's a very handy feature. So in this case, the asset name, we can define it as $name, which is the default. And if we do, it will use the name we've defined for the template. And we could apply that name in other places. We could also say name_test, for example, and the $name will get filled in with the name. There are other variables as well for IP addresses of things, and this is true across the north and the south. So we'll click Save, and then we'll walk back out, and now we can see in the machines that pump 4 is now connected to pump FogLamp 24. And back on the FogLamps page, we can see there's now a connection to that FogLamp. Now we can go to the external systems. We'll walk into Pi, and we'll add a new connection. And here we'll use OMF Pi server. We'll give it a name of Pi 1 Fog 24, and we'll send it to FogLamp 24. And in this case, we're just going to use the same producer token as used before, just to simplify this demo. But you'll see there's another variable here for the server host name, the Pi server that we're going to connect to, which in this case is $destination address, which is the IP address of the Pi server. And this, again, we've defined for the Pi server, we've defined an IP address. And then each of these connections is a configuration for a specific FogLamp. So you can imagine having hundreds of FogLamps out there, and if you wanted to change the Pi server address, if you didn't have FogMan, you would individually go to each of them and change that IP address. Here, you can just change that one address for the Pi server from 10.0.10.5 to something else, and then it would automatically change all of the connected FogLamps. And I'll click Save. And now we'll walk back, and again, with FogLamps, you can now see that we've got a Pi connection for this Fog24 and a leakage connection on the south side. So now I'll deploy that connection. And it tells you it's deploying. And FogLamp is quite smart, by the way, when it does the deployment. So versions exist across all the FogLamps, but FogMan and FogLamp only bring down any services that are absolutely mandatory during these update processes. So if you have a south service that's running that there's no reason to bring it down, then you won't lose any data. And of course, if you're making a change to one of your FogLamps, in this case Fog24, we don't bring down any of the other FogLamps as part of that. So now once we've deployed that, we can see that we start to see some ingress and egress. So in this case, Fog24 has brought in 3 readings and has sent those 3 readings onto Pi. And every 20 seconds, you'll see that updated. And also as part of that configure, so in this case, we just added a sensor and we added a Pi server, but you can do more complex configurations too. So for example, we can walk into the FogLamp, we can look at the south configuration, we could set the readings per second or more advanced configurations. We could also update the software. So in this case, these are the pieces of software that are installed on that FogLamp. We could update those, or we could also update the schedules. So FogLamp has a very powerful scheduling subsystem. So it does backups, it checks their certificates, it does purging of the data, it does stats collection, and so forth. And you could manage all of the schedules in this as well. And just to give you a feel for where we're going with this, in upcoming versions we intend to add functionality such that you'll have some status of your machines here in the machines section. So you'll have green dots next to them, and those green dots will represent whether that device can actually, whether we're collecting data from that device, and whether that device is, whether the data we're collecting appears to be healthy. So for example, you could set something such that if the temperature is excessive, or if the vibration indicates that there's a bad bearing, or something else, that you'll start to see much more functionality around the health of the machines. So that's FogMan, and hope this has been valuable. And please reach out if we can help with anything. Thank you.